Good morning, everybody. The today's outline of the class is development testing. Before the development testing, introduction about the software testing, in the previous class. So today, say only the regarding the development testing. So the software product contains number of testings. So software product contains number of components, number of units, and the integrating of all these components to it becomes as a system. So each should be testing. So development testing includes all the testing activities that are carried out by the team developing the system. So all this testing should be carried out by one team or team it is developing the system. So the all three types of testing. Unit testing. So unit testing where individual program units or object classes are tested. So unit testing should focus on testing the functionality of objects or methods. So the functionality of each object should be correct or wrong. It must be tested or methods. So this is called units. So in one component it contains the number of units. So next is a component testing where several individual units are integrated to create composite in components. The component testing should be focused on testing component interface. So the combination of all the components it becomes as a system. Next, system testing where some or all of the components in the systems are integrated and system is tested as a whole. The whole system is tested should focus on testing the component interaction. So interaction use correct or wrong. So development testing should be carried out by three. One is the unit testing, component testing, and system testing. So unit testing, each one is given in detail. That is, the unit testing is the process of testing individual components in the components isolation. It is a defect testing process. Units may be individual functions or methods within an object or object classes with several attributes and methods. Composite components with defined interfaces used to access their functionality. So any one of these called as a units may be. So object class testing. So complete test coverage of class involves testing all operations associated with that object, setting and interrogating all object attributes, exercising the object in all possible states. So inheritance makes it difficult to design object class test as the information to be tested is not localized. Here is one example is given, the weather station object interface. So it is one object. It contains the two. One is the functions and attributes identifier. The weather station testing need to define test cases for report weather, caliber, test, startup and shutdown. So all these are given. Weather station testing. Automated testing. Whenever possible, unit testing should be automated so that tests are run and checked without manual intervention. Automatically checked it. In automated unit testing, you make use of test automation frameworks such as JUnit to write and run your program test. The unit testing program provides generic test classes that you extend to create specific test cases. And automated test component setup parts where you initialize the system with the test case, namely the input and expected output. It is a setup parts, and a call part where you call the object or method to be tested, and an acceleration part where you compare the result of the call with the expected result. So these are the automated test components. If the acceleration evaluates to true, the test has been successful. If it is false, then it has failed. So choosing input test cases, test case should show that when used as expected, the components that you are testing does what it is supposed to do. If there are defect in components, these should be revealed by test cases. This leads to two types of unit test case. The first of These should reflect normal operations of the program and show that the component work as expected. On the other kind of test case should be based on the testing experience of where the common problem arises. It should use abnormal input to check that these are properly processed and do not crash the components. So testing strategies, there are two strategies. One is a partition testing, another is a guidelines based testing. So where you identify the group of inputs, you have to partition the group of inputs that have common characteristics and should be processed in the same way. So each group can processed in the same way. So that is called partition testing. So these are the testing strategies where you should test from within each of these group, and another testing is called as guideline based testing. So where you use the testing guidelines, based on that guidelines to choose the test cases. These guidelines reflect the previous experience of the kind of errors that programmers often makes when they developing the components. So partition testing, there are two strategies of this partition and guideline testing. So the first one is the partition testing. Input and output result often fall into the different classes where all members of the class are related. So each of these classes is an equivalent partition or domain where the program behaves in the equivalent way for each class member. So test cases should be chosen from each partition. So this is given as a equivalent partition, input equivalence partition, and given to the system, and it used the output partition, possible outputs. So it's given example also less than 4, so 1 to 4, and between 4 to 10 you have to partition it, more than 10, so this is the equivalence partition example. So testing guidelines, so based on the two strategies, based on the guidelines and based on the testing partitions, partition testing and testing guidelines. So testing software with sequence with have only single value. Use sequences of different sizes in different tests. Derive tests so that the first, middle and last elements of the sequence are assessed. Test with sequence of zero length. So general testing guidelines. So these are the general testing guidelines. Choose input that force the system to generate all error message. So this is the first the guidelines. Design the input that cause input buffers to overflow. Repeat the same input or series of inputs numerous times. Force invalid output to be generated. Force computation result to be large or small. So component testing. So software components, it contains number of units. So are often composite components that are made up of several interacting objects, and you assess the functionality of these objects through the defined component interface. Testing composite components should therefore be focused on showing that the component interface behave according to its specification. So next is interface testing. The objectives are to detect fault due to interface errors. So all are connected with the interface, all units are connected with the interface, all components are connected with the interface. So objective are to detect the fault due to the interface errors or invalid assumption about the interface. So interface types it may be parameter interface, it may be shared memory interface, procedural interface, message passing interface. So based on this, it find out the errors. So parameter interface data passed from one method or procedure to another. So shared memory interface, block of memory is shared between the procedure or functions. Procedural interface subsystem encapsulates a set of procedure to called by the other subsystem. Message passing interface subsystem request service from other subsystem. So this is the diagram for the test case is given interface error. There are three kinds of the errors is given: interface misuse, interface misunderstanding, and timing error. A calling component calls another component and makes an error in its use of its interface. It is called an interface misuse. The example is given parameter in wrong order. So interface misunderstanding, calling component embeds assumption about the behavior of the called component which are incorrect. The called and calling component operate at a different speed and out of date information is assessed. Both are in different speeds is called a timing error. These are the interface guidelines and system testing. The whole system testing during the development involves integrating all the components to create a version of the system, first version, second version like this, and then testing the integrated system. The focus in system testing is testing the interaction between the components and interaction between the units. So system testing checks that components are compatible, interact correctly, and transfer the right data at the right time across their interface. So system testing tests are emergent behavior of the system. So system and component testing. During the system testing, reusable components that have been separately developed and off-the-shelf system may be integrated with newly developed components. The complete system is then tested. So reused components and the complete system is then tested. The component development by different team members or sub-teams may be integrated at this stage. System testing is a collective rather than individual process. So these are use case testing. Use case developed to identify the system interaction can be used as a basis for the system testing. Each use case usually involves several system components, so testing the use case forces the interaction to occur. The sequence diagram associated with the use case documents the components and interaction that are being tested. So this is a diagram for collect weather data sequence part